All right. Okay. Uh, right here, what we're going to get into is we're going to start looking at the optional. We did the standard last week, and we give you a lot of stuff here to look at. And you're going to see we give you all the loads. We separate them here so you can figure out how to do all this. Now on the bottom left hand side, you'll still notice we still have the dot that's there for sizing the phases. When you get ready to do the neutral, you're going to have to go back to the standard calculation to get that. Okay. Now
Hey,
all
real quick, Juan has a comment for you.
sure.
Yeah, that's a good comment, Juan. A lot of field electricians don't
They
look
don't.
at that.
And that's one reason that uh, we've taken the new grounding and bonding book that's going to be coming out here hopefully by the end of April, 1st of May, somewhere in there. We've gone in and I think everybody's really going to like this. Matter of fact, since we're getting questions, let me look here real quick. um, I have taken and uh, done a lot of the illustrations here so everybody can sort of see just exactly what we've done. Let me look here and see what I've done with it. Um, Here's a PDF. Okay, let me open this up and everybody can sort of get an idea of what you're going to see. Now, if you see a mistake in here, I don't want to hear anything about it because it hasn't been completely edited yet. We're in the process of doing that. So, but this will give everybody an idea of what you're going to see that is going to be coming up in our new stuff here. So, here will be the new grounding and bonding book. And uh, as you come down and look at this, I want to get into some of the other stuff here. But like this is a good example here where we're showing the effect of ground fault current path. This is just getting you started. But you can see how we've drawn the panel boards, the disconnects, the motors, everything. And we're showing all the grounds and everything, how they're connecting inside. So we've made quite a few changes to update these. But let me go over here and I'll show you some really good ones here. Get down here where we start looking at. Let me go down here. Let's see. I want to get about right in here. I think I want to be. Yeah, we'll get in right here. Okay. This is where you get into like your grounding electrodes and stuff. And you'll notice in the colored version, you're going to be able to see we've colored all the wires. So you're seeing the wires go over there. They'll be in green. You come over here, you pick up your concrete encased electrode. You pick up your ground ring. You'll notice we've done everything to show where everything's connected. Uh, it, it is really going to be awesome the way that this is done. Another thing that we've done here, and I think this is pretty good here. If you look at the top left hand side, we talk about the supplemental electrode and everything. And I want
Uh-huh.
to point out, you're going to notice right there where we got the two rods beside each other. We're saying if you had a 6 foot rod to go 12 foot, well, we give explanation behind this, and this is IEEE. Basically, what that's
Right.
telling you is you're not impeding on the other rod's resistance. Okay,
Yeah.
and we
It,
go
it
through.
wouldn't it wouldn't be a code violation unless you went closer than 6 foot. But you're just saying like an engineered
Yeah, but
prime.
if you're out on the job and you see in your engineering prints they tell you to be 12 foot, there's a reason. Okay,
Okay.
and we go through all that. We go through like the next one over there. We've got new drawings here showing you the different softening devices. Uh, just as you go through all of this, you're going to see like this one right here where we get into the auxiliary grounding electrode, showing you all the connections and everything here. And then we're showing you going to the ground rod. Now, one thing you'll notice that we did miss because you got a white background, like at the top of that illustration, you'll see it's got a dotted line with gray behind it. That's just so you can see the white conductor. Okay?
Okay.
So we've done stuff like that. I'll show you. I'm trying to remember just exactly.
Yeah, we did
But
recently do a myth on the water softener one, like if you have to jumper it, and a lot of people don't think you have to jumper it because you only, like the code only says you have to hit it within the first 5 foot of where it enters the building, but you also have to jumper that whatever kind of equipment you have in that line to make sure you ensure continuity in case that water meter, that softener is replaced or anything.
sure. And this will give you an example, and you won't see this in other publications, but it gives you an idea of the level of detail in the book. This illustration that's on this page on the right hand side, if you notice right over here, this is a recommended chart, okay, based on the size copper water pipe you have coming in, and the maximum size that you can put on that grounding electroconductor to that metal water pipe. Okay,
Okay.
and this is recommended by the Metal Water Pipe Association or whatever they're called. But we got
Nice.
this from them, and we put this in there. And this is what I'm telling everybody: is you're going to get to see a lot of things in this grounding book that you're not going to see in others. And the reason is because we've worked for, I mean, you're looking at Dad 50 years. He's learned a lot of different things from people in the industry and things that they've looked at from people that have been on the panels that have come in and made uh, 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 comments, I guess you could say, of what they want to see happen. And that's where you get in and you start looking at all of this stuff here. So
Nice.
it's very in depth. I think the illustrations speak for themselves.
Yeah.
They're very detailed. A lot of information is in them. They've redrawn everything from meter bases, panel boards. I mean, you take your pick. It's just
I
loaded with new stuff.
I only have one complaint with your publication.
What's that?
There's a lot of floppy nipples in there. So, all
Gotta
right,
have
I'll
some
let you.
copy.
There you go. All right, I'll let you get back.
Okay.
Sorry for the
So
interruption.
this in here, we get into optional load calculation. This will be based on 220.82. And we give you the information here, and we're going to be looking at doing the general lighting and receptacle load. You'll see we have a 2,800 square foot dwelling unit, 2 small appliance circuits, and 1 laundry circuit. Then you got all your 120-volt loads. You got a 2,600 VA water pump, 1,000 VA disposal, 1,200 VA compactor, 1,600 VA dishwasher, and a 1,000 VA microwave. And then you got your 240-volt single phase loads. I'm just not going to cover everything, but what I am going to show you here is, and I want to point this out, when we were looking at the standard calculation, what is the one thing we did? We looked at it and we would automatically know we needed to start getting rid of some loads. Okay,
Yeah.
so I would get rid of the oven, the cooktop, I'd get rid of the dryer load and the heating and AC. Now, when you're doing the optional, you're going to do it totally different. You're going to take and just add all those loads up together. Okay,
The
so
one thing I do like is I like how you break it down. I feel that you do it in less steps than anybody out there.
well, it comes down. You got to put it in a grouping, and once you
Yeah.
learn the grouping, it's simple. I mean,
Yeah.
calculations to me in the code, they're simple. Once you understand the process and the step by step procedure, it's really not that hard. And I think, I've had a lot of people that have messaged me, been thanking me left and right for doing this series on calculations and saying they actually understand how to find it now and what they're looking for. They said
That's
before that
awesome.
they say hadn't had anybody explain it like this,
Nice.
and that's one of the things we try to do is make it as easy as possible for everybody. So just to
Oh
show
yeah.
you how to do this, step one, you got your general lighting load. We know you're going to look at 220.82B1 and it's going to refer you to 2014J. You're going to take it at 3 VA per square foot, same way you do your standard. So that's going to give you 8,400. Then you got 1,500 VA for each one of the small appliance and laundry loads. That'll give me 3,000 and 1,500. Then if you go look at table 220.82 B3 and 4, I'm just going to add all the rest of the loads together right here. We'll just call it the fixed appliance load. Okay, everything goes left right here. So you just put all those together. It's going to give you 59,100 VA. Now, when you look at 220.82B, what does it say over there? Well, as you look at that section and you read the text, what it says here is this. It says, I'm sorry, that's the wrong one. It says, for your general loads here, the general calculated load shall not be less than 100%. Now listen to this, of the first 10 kVA and then 40% for the remainder. Okay, right. So I'm going to take the first 10,000 at 100%, whatever's remaining at 40%, which would be 49,100 at 40%. That'll give me 19,640 VA. Add that up, gives you 29,640 VA. And then I need to determine which is the largest between the heating and AC load. Okay?
Right.
Now, if you look at this, I can already tell you this. It says when I look at 82C1 and C2, and I come down and I pick up C4 there, it talks about the electric space heating. It says if less than 4 separately controlled units, you take it at 65%. Okay, right. So I'll take the 10,000 at 65%, gives me 6,500. That's larger than 6,000. So just add those up, divide it by 240. That gives you your amperage. Okay.
Nice.
Now, the next thing you're going to do is just look at table 310.16. The next size above that is a 2-aught, which is good for 175 amps. Okay, we right. barely missed the 3-aught at putting that in. I'm sorry, not 3-aught. It's been a long day. 3-aught's 200 amps. I'm getting tired. Okay.
It'd be 1-aught, right?
Yeah, 1-aught. I just don't know why I'm saying 3-aught. Now, if you look right here and you come down and you look at table 310.12, let's go over and take a look at that and see what it says. Table 310.12. When you pick,
so this is all 2020, right?
Yes, it's 2020.
Okay, because I think that's changed. I think that's changed for 2023.
It has, but that's why we kept everything on 2020. 2023 is not updated yet. All right. So when I come over and I look at my single phase dwelling services and feeders, I come down. I was at 151 amps. Come across, pick that up. The next size above that's 175. And what does it say I can put there for a copper conductor? 1-aught.
Yep.
Okay. So that's how you want to go about looking at this. So let's recap real quick, because we're going to get into multifamily dwellings in a second. And what I'm going to tell you is, once you got the dwelling unit down, multifamily is exactly the same way. It's just you're going to do it by the number of units. Okay. Mm-hmm. And then you'll remember I said, when I get over and I start looking at table 220.42, that the first 3,000 is taken at 100%. Then I'll take the 117,000 after that, 35%. Anything that gets over 120 after that, then we'll take it at 25%. You're going to see that when we get over to doing these multifamily dwellings. Okay. Now, the other thing I want to point out as a recap here, if it's a standard calculation, we have 6 groups. Okay. You had your general lighting and receptacle load. Then you had your small appliance branch circuits and your laundry circuit. So that's one load we were doing all together. Okay. Then we went and did our cooking equipment loads. Then we did our dryer loads. And everything that was left other than the AC and heating unit, which we'll do separate because that's a non-coincident load. Everything else fell in where? The fixed appliance load. Okay. Then we went heating and AC load, then largest motor load, and that's your grouping right there. Now when I get here to optional, you're doing all exactly the same thing. You're just going to add everything together except the heating and AC, and then take the first 10,000 at 100%, and anything that's left over at 40%. Then add your non-coincident load between the heating and AC load, whatever's the largest. Add those together, then divide it by your voltage, and that'll give you your amperage. Okay, so that should be the way you want to remember when you're doing these calculations. Now, look at this. And this one here, we're going to have 25 multifamily dwelling units. Okay. Now, we'll look at this real quick, but I want to point out top right-hand side. You'll see we'll have a dot there for your phases, and then we'll have the check mark there that's going to be for your neutral. Okay. Just like we did last week when we were doing the standard calculation. Now, we got 25 units that are 1,000 square foot each. We got 2 small appliance circuits for each unit, and we got 1 laundry circuit per unit. And then our 120 volt single phase loads, we got 25 1,000 VA dishwashers, 25 1,200 VA disposals, and my 240 volt single phase loads. You'll notice we got 25 of everything. We got 12,000 VA ranges, 25 6,000 VA water heaters, 20,000 VA heating units, and all the dryers are natural gas. If these were electric, then we would have 25 there to do that. So you may get a test and they'll tell you that the dryers are natural gas. If that's the case, don't worry about that. It's not going to be calculated into the calculation. Okay. So let's take a look at how we would look at this. First, we got our general lighting and receptacle load. Okay. Same thing. I'm looking at 220.14J just like I do for one residential unit. The only difference here I'm doing is adding the 25 units on here. So I'm taking the 1,000 times 3 VA. So that's 3,000 times 25 units gives me 75,000 VA. I've got 2 small appliance circuits for each unit. Each small appliance per 220.52 A and B for the small appliance and laundry unit is good for 1,500 VA. So once again, you've got 2 small appliances. That's 3,000 times 25 units is 75,000 again. Then I've got 1 laundry circuit per unit. Take that at 25 units, gives you 37,500 VA. Add it all up, you got 187,500 VA. Now, those that are following along, go look at table 220.42. Now, you'll notice we're giving you all the sections here, so you'll know where to go find this information. And it tells you it's the very first one that deals with dwelling units. First 3,000 at 100%. The next one, now some people mess this up. Some will put 120,000 here. You've already done 3,000 of it, so it's up to 120,000. So it'd be 117,000 VA. Okay, so you'll take 117,000 VA at 35%, gives me 40,950 VA. And then I'll look at my remainder here. It tells me anything over 120,000, I take it 25%. Well, the remaining VA I had was 67,500 VA. Take that at 25%. That'll give you 60,825 VA. Now, if you look at that, it was the same calculation we performed for a single residential unit. We did not do anything different here. The only difference I did here was add the 25 units to each one. And then when I got down to step 3, I was over 120,000. So I had to take and do that additional VA. Okay, at 25%. All right.
Nice.
Yeah. Now, cooking equipment loads. I had 25 12,000 VA ranges. Now let's go over and let's look at table 220.55. I come down, I pick up 25 units, I come across, and you'll notice I'm not over 12 kVA, and I'm more than 8 3/4, so I'm in column C. You just come down and it tells you it's good at 40, so that'd be 40,000 VA. It's already given to you.
Okay, and so this is a multifamily optional, or is this a multifamily standard?
This is standard.
Okay, gotcha.
This is standard. I think I said that at the start.
I just, some people came in late, maybe.
Oh, okay. Now, if you look at 220.61, and you're looking at your calculation here, you get into where you got permitted reductions here. Okay. And it's going to tell you here that I can take that 40,000 for my ground and neutral conductor at 70%. Okay. So I'll go ahead and figure out my neutral here. That's 28,000 VA. Now, if you'll notice right on the right hand column, we're keeping it step and step here. So when you're doing this on test, I would get used to doing whatever you want to use. We use a bullet and a check mark. But right there, the total load for the general lighting and receptacle load, that is for my phase and neutral. And then when I come down and I look at my cooking equipment load, the 40,000 VA is for the phases and the 28,000 VA is for the neutral. That's where the bullet and check mark are. Okay?
Nice.
Now, the next thing I'm going to be looking at is everything that was left because I didn't have a dryer load because it was gas. So I'm just going to add everything else here except for my heating and AC load. Now, we automatically know we're over 4. So we're just going to do every one of these at 75%. Okay? So I had 1,000 VA at 25 units of that. I don't remember exactly which one it was. Let me go back and look. So go back. So we had the dishwasher at 1,000, disposal at 1,200, and then the water heater was 6,000. Okay. So looking at this right here, I'm going to take and I'm going to add these up. I got 1,000 VA, 25 of them at 75% gives me 18,750 VA. 1,200 VA times 25 units at 75% is 22,500 VA. 6,000 VA times 25%, which was my water heater, take it at 75%, gives me 112,500 VA. Add them up, so that's 153,750. Now let's go back here. What was my neutral load ones? Right here, here's my 120 volt single phase loads in the middle here, and that was my dishwashers and disposal. So I'm going to do those individually right here. Okay?
Okay.
So I'll just pull over the values I've already calculated and leave out the water heater, and that'll give me 41,250 VA. Put a check mark there. There's my neutral load. Okay? So far, pretty simple. All right? Now let's go back and let's look at my heating load here. You're coming back. I've got a heating load here of 20,000 VA. Okay? Come back. I got 25 units there. That'll give me 500,000 VA. That's my phase load. Now I'm just going to calculate what is my largest motor load. Well, I'm looking up there. The largest motor load up there is 1,200 VA for the neutral and the phases. So I'll just take that 1,200 at 25%. It's going to give me 300 VA for each one of them. Then you've done everything at this point. All I'm going to do here is add everything up. I'm going to come over here, take all my phases, add them all up together. That's going to give you 754,875 VA. Take all the check marks that were your neutral load, add them all up together, gives you 130,375 VA. And then I'm just going to divide each one of those by 240 to get my amperage. And my phases will give me 3,145 amps, and my neutral load was 543 amps.
Okay.
That's a simple. Now, you're just looking at it. You're going to parallel those conductors. We didn't go through all that. We actually have another problem where we go through and show you how to parallel. We don't do every one of them. Okay?
All right.
And here is you won't see us on every one of them, but here's one right here. We said we're going to parallel this 9 times. That's 349 amps for my ungrounded phase conductors. Okay? Now, if I paralleled those 9 times and excuse me, I think that got me.
Yeah.
So if I look at this, I've got 349 amps. Okay? Let's go look at table 310.16 and see what I need here. Okay?
Well, you got to watch out too because they might turn it up to 363 amps or 368 amps or something, you know?
Well, that's something that Paul would try to do because he didn't understand what he was looking at. So if you go over and you look in your 75 degrees C column, we paralleled that 9 times. You come down, the next size above that is 380 amps, which requires what? 500 kc mil conductors. Okay?
Yes, sir.
Now let's look at my neutral load. It's going to allow me to also put 70% on top of this again. Okay. Now, when you go look at 220.61, we have the load that we did 70% on for my cooking equipment load. Okay. Now you're going to come over because you're doing 70% also, because you get 70% for your general lighting and appliance load also that are there, and all your fixed appliance loads. So we had 543 amps, and it tells you over here you can take the first 200 amps at what, 100%, and then the remainder you can take at what, 70%. Okay, so you take that 343 amps at 70%, that gives me 240 amps, which is 440 amps, and we paralleled each run 9 times. That's going to give me 48 amps. Now, you would go over and look at table 310.16 and automatically you'd say, oh, I put number 8 there. No, you can't. Because if you go look at 310.10H, it tells you they have to be at least 1-aught conductors if you parallel.
Yep, I agree.
So that could be a trick on the test.
Hey, I'm going to have to stop you for a second, James. We got a dun, dun. We're going to have to get a sound effect every time. Dun, 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 dun. Daniel J shows up, and that's awesome that you are 100% correct, Daniel. I had one question on my exam for the dwelling unit load calc. Yeah.
When I took mine way back, we actually had to figure up a standard calculation, a single dwelling unit, and then we also had to do a commercial calculation. And then I also had to do a motor calculation. The size, it was 4 motors. We had the size of the conductor and the overcurrent protection device. Those were my 3 calculations when I took it.
And it's just like the way we look at it. It's like if you're going camping, we just want to make sure you have a tent, sleeping bag, water, emergency preparedness kit. You know what I mean? Like, you might not use any of them, but you know what I mean? You're going to have a good time camping. So that's the way I look at it.
Now, this one is the exact same calculation, but it's optional. And you'll see that we tell you to look at the standard calculation in problem 14 that we just did for the grounded neutral conductor, just like we did previously on the optional calculation for a single family dwelling. Now, when you come in and look at this, let's see what you do here. Oh, looky there. I'm adding all the loads up again. I'm not doing anything like the standard. I'm just going to take all these loads and add them up. So we've already done the calculation for the general lighting and receptacle load. We said that was 75,000 VA. We had 2 small appliance circuits for each unit. That's 75,000 VA. Then we had 1 laundry circuit per unit for 25 units there. That's 37,500 VA. That's 187,500 VA, which is what we had in the previous calculation. Now you're looking at the cooking equipment loads. You're going to take the 12,000 VA. If they were 10 kVA, you'd take it at 10 kVA. If it was 10.5, 11, whatever. This one, we're going to take the 12,000 VA at 25 units, gives me 300,000 VA. Then we go down our fixed appliance load, same thing. You had 1,000 VA times 25 units, 1,200 VA times 25 units, and 6,000 VA times 25 units. Same loads that we calculated earlier, added up, gives you 205,000 VA. And then you had your heating load. The same load we had for the standard calculation was 500,000 VA. Then just add them all up together. That's it. So I add all these loads up together. That gives me 1,192,500 VA. Okay. So we had a single phase 120, 240 volt system. Divide the 240 into it. That's going to give you 4,969 VA. Now, let's go look at table 220.84 and see what it says. It'll tell you there in the table, it'll say optional calculation, demand factors for three or more multifamily dwelling units. We had 25. We come down and look at that. it tells me straight across, I'm able to take and apply a demand factor here of 35%. Okay.
Okay.
So what I'm trying to point out, when we started our optional first, we looked at 220.82 for a dwelling unit. Then if you go over to the next page, then you pick up 84 and it'll say the heading multifamily dwelling. Okay.
Right.
So I'm doing multifamily dwelling. I've got 25 units. I'm doing optional here. That's going to tell me I can take it at 35%. So I take that 4,969 amps at 35% gives me 1,739. Now we just put this together. You may want to go 8 runs of parallel. It's up to you, whatever you want to do. But we did 6 parallel runs and we divide that into the 1,739 amps. That gives me 290 amps. All right. So let's go over to table 310.16 again and look at that table. And if I come down in the 75-degree C column, the next size above 290 amps is 310 amps. Come across, and it's going to tell me I need a 350 kc mil conductor.
Okay.
Now, in the previous calculation in the standard, what was my ground and neutral conductor size? A 1-ohm. It was, 54 amps or something? And I said 58. I said, if you use just the table, you may think of number 8, but remember to go look at 310.10H for parallel conductors. And it tells you the smallest it can be is a 1-ohm conductor.
Absolutely.
Okay? Now,
Well, and I just want to be clear. There was a little confusion because I think this was Willie Jackerson tried to make 2 units of multifamily, and they said it had to be 3 or more. But it was just Willie got shut down on that one.
Well, so, and what I want to
that's where that came from. If anybody was wondering,
the only thing I want to point out so far is I haven't changed my calculation method, my step-by-step procedure. Everything has stayed the same for standard or optional calculation. The only difference was the number of units and looking at a different table to do it. That's it.
Yeah.
Other than that, I did not change how to get to that point. And then once you get to that point, then you know where to go and get these derating factors and stuff to apply so you can size that conductor properly.
Yeah.
All right. Now.
All right. David Englehart's out. Hey, good night, David. Thanks for jumping in here, and feel free to listen anytime you want. And we love having you in here, Mr. Englehart, Mr. E. We love having you, Mr. E and Mr. G.
All right. Now, this is a mobile home, and we're going to be looking at doing the same type of method here. And you're going to see we're going to do the bullet and the check mark here. And I'm looking at this, and I'm automatically thinking, how am I going to start doing my loads? And I think of it because I'm doing a standard calculation here. I do something different when we get to optional, but here I'm looking, I've got an 800 square foot dwelling unit or mobile home, 2 small appliance circuits, 1 laundry circuit. And now I'm going to be looking at what loads would I delete from the fixed appliance load. Well, I know the 8500 VA range is not going to be there. The 6000 VA water heater is going to be an appliance. The 5500 VA heating unit, that's not going to be part of the fixed appliance. Then I got a 500 VA disposal and 800 VA dishwasher. Okay? So let's look and see what we come up with. All right? I'm going to look at this. I've got an 800 square foot dwelling unit, 2400, 2 small appliance circuits, 1 laundry circuit. Each one of those are 1500 VA, so give me 3000 VA for the small appliance, 2 of them, 1500 VA for the laundry circuit, add up 6900 VA. Now, if you look, I go back and it's going to tie straight in. Matter of fact, this will probably be pretty good at this point. If I go over, and I think this is interesting for everybody to look at because I know what it says. So, but sometimes it's good for people to see how am I doing the exact same type calculation that I do for a standard calculation when you're giving me all these other sections. Well, the best way to pull that out for you is go over and look at it. So if I take and I look at 550.18A and just say we're looking at the lighting here, it says length times width, mobile home for blah, blah, blah. It says, for example, length width time what? 3. And then if you look at 18A2, small appliance branch circuit, and then you get your laundry circuit in 3, it tells you take it at 1500 VA. Okay? So everybody sort of asks, well, I ask this question. This is where you're going to go to get them sections. It's the same type of principles that we're applying for everything else. Okay?
Dude, I'm just so happy that Willie can calculate his double wide the same as Daniel J's mansion down there. So.
Oh, yeah. All right. Now, if you look at 8.5 net volt amps, what does it say? First 3,000 total volt amps at 100%, and the remainder at what? 35%. Well, if I went back and looked at table 220.42, guess what it says? Exactly that. Okay? So I'm just going to take and I'm going to add all that up, and the first 3,000 at 100% is 3,000. The next remainder, 3,900 at 35%, gives me 1,365 VA. Okay? Then I'm going to come down and look at my special appliance loads. Okay? Well, if you look here, I got a water heater at 6,000 VA, a dishwasher at 800 VA, a disposal at 500 VA. Now, if you'll notice here, why did I just go ahead and put the heating and largest motor there? Some will look at that and say, why don't you do that? Well, let me explain why we did that. Because if I go over and let's go back and do some research here so everybody knows where I'm going with everything that I tell you here. If I'm looking at my fixed appliance load and I go over and I look at 550.18 B2, B3, and B4, I'm going to look at all of this, tie this in. If you notice here, for my fixed appliance load, how many of them did I have? 3 or less. If I'd have been 4 or more here, then I'd have taken it at what?
50%.
75%.
Oh, 75.
See there? I didn't do any of that here. So I just said, okay, there's no need to add another step here because it's just all going to go together. So I look at what is the largest motor load here. It's the disposal. I'll take that at 25%. Gives me 135 VA. Just add all the loads up together there, and that'll give you 12,975 VA. And then I'm just going to look at my range load. Now,
gotcha.
Now, this gets interesting because let's go take a look at this and see what it says. I'm going to look at 550.18 B5. Now, as I look at this section right here, one of the things that you want to pay real close attention to is what is it going to tell you to do here, okay? So if I look at 18B5 and I come down and I pick it up, you're going to see that it's going to, let me go here for 1 second. I want to add something here. Let's see.
I should have invited Willie because he's better on the mobile home codes.
Mobile.
I'm not that good on it.
Okay.
I do like the two-family home, the single-family home calculations.
Okay, so as I'm looking at this section here, let's take a look at this. Now, I've got 8,500 VA range load. Okay, now this is going to get me back to where I'm going to look at table 220.55. Now, if you look, I'm over 3.5 kW up to 8 3/4 kW. Okay, you remember me doing this 2 weeks ago, I guess? And you come across, and I said, when you're looking at this table, right up at the top, you're going to see demand factor, and it's going to have a percentage there in parentheses for column A and B. So if I have 1 unit, it says to take that at 80%. Okay? Now, if you look...
I'm not trying to stop you, James. Juan makes a good point. He's basically telling me that I should tell you that you a lot of times you're saying the phases, and it's not. It's one single phase. So basically, it'd be called like A leg, B leg. So
okay. Yeah.
that's a good comment, Juan. I've told you that before. It's a standard habit for me too, James. So I
I
just
do that.
wanted
I
to
don't
let
even
you.
think about it. I say that's your phases.
Yeah,
I tell
but
you,
it's just something just to clarify for people out there that James oftentimes says phases, but he means the legs of one single phase. So
yeah,
you
the
have an A
single
leg
phase.
and B leg. James didn't even catch a few times when we were in the thing. Juan, I've been like, "Hey, is that two phase? Is that two phase, or is that single phase?" And then he's like, "Oh, it's single phase." I'm like, "Oh, okay. I just want to make sure, you know." But it's just we just joke around a lot, and sometimes James don't catch it, but it's funny. He'll catch it like in episode number 27.
Yeah,
You know.
it's just a habit of mine, just saying phase, isn't it? I know it's single phase, As a matter of
Yeah,
fact, thank you, and then the problem that said that.
yeah.
So as you're looking at this, we're going to take that at 80%. It's going to give me 6,800 VA, and then of course I can take that to get my neutral load at 70%. So I'll take the 1,600 VA at 70%, give me 4,760 VA. Now all I'm going to do is just add all my phases up here. I had 4365, 12975, 6,800. Give me 24,100 VA. Divide it by 240 volts gives me 101 amps. Okay. Then calculate all your neutral loads. I've got 4,365 for my general lighting, small appliance, and laundry load. Then I had my dishwasher there that I checked at 800. My disposal I checked at 5,400 VA. Then my largest motor at 135 VA is 120 volt load. And then my neutral load at 4,760 VA. For the range load, add those up, 10,600 VA. Divide it by 240 volts gives you 44 amps. Okay. So, and I'm not going to go through all the conductors, everybody. We've already done like 3 problems on that. Y'all know where to go and look at table 310.12 also. All
Nice.
right. Now, that brings me into looking at a mobile home park, and we're going to do this where we're going to do it in optional. Okay. So for this one, I've got 28 mobile homes in this park. Okay. And I'm going to
Okay.
size the secondary electrical distribution system. And what you're going to see, we're going to parallel this 3 times per phase. We got 28 units there, and we're just giving you exactly what each unit's at. We're going to say each one of them are calculated based on the load here, typical for a mobile home that the code lot will accept is 17,000 VA. Okay. So I'm going
Yeah,
to
and
take,
this is like a really important one for like the green apprentices out there, or not even just the green apprentices, but like some of the first time journeymen. Like sometimes your boss will go out there and be like, "Hey, go hook this up," and we got to go calculate this and be like, "Hey, what do we do after the last 13?" You know, like if
mm-hmm,
you can't do this calculation, then you have to make sure that you're covering your ass when you're on these situations and you're just going, "Hey, I just did the calc on this and you're under by 13,000 watts." So I just wanted to stress the importance of this. I've actually been in this situation before. I did the calculation and they were not even close.
yeah. And,
So,
and this is typical, what you'll see that they'll do the calculation at 17,000 VA. Now this one, we
yep.
got 28 units. Now, if you go look at table 550.31, this is where you're going to pick up the demand factor here for the total number of mobile homes. And if you come down and pick up 25 units, it'd be 22 through 40 come across. It'll tell you can put a derating factor of 24% on. Okay.
Right.
So I'll put that 24% on there, and that'll give me 114,240 VA. I'm done. This is about as simple as it gets. Then you're
Yep.
just going to divide that 240 volts in there. That'll give you 476 amps. And then I'm going to parallel this 3 times, which is going to give me 158.7 amps. And if I look at table 310.16, the next size above that is a 2 alt, which is good for 175 amps. Okay.
Nice.
Now let's look at the neutral. The neutral is exactly the same calculation that I was looking at. The only difference is when I get to step 3, I can take it at 70%. So
Right.
I'll take the remainder after the first 200 amps at 100%, which is 276 amps. Take that at 70%, that gives me 393 amps. And then I divide that by 3, that'll give me 131 amps. Well, we automatically know that if I'm paralleling something per 310.10H, I have to at least put a 1-aught on it, which actually works out for this calculation anyway.
Right.
Okay? And
Yep.
that, my friends, gets you through doing the